Hello everyone, welcome to another video where I go over some Excel basics. So we have, similar to our last video, a calculation area and a graphing area on the right. If you didn't catch the last video, I have our tests. We have interval 1, 2, and 3 for this specific lab this week. These will be your lengths. Length 1, length 2, length 3, whatever they may be, you're going to have about 5 or so. Underneath that, we have our period measurements. We have, I just filled in random data for this example, but we have 10 trials. In this experiment, we're going to have 20, so imagine a table that is double this. Okay, in each column, it goes like this. The data is averaged down below. In the last video, I have shown you how to find this average by using the built-in function. We've also found the standard deviation the same way. And the only thing that was different was finding the standard error. We had to go in and make this math formula ourselves. Up on the top right, we have our graphing area. This is where I sort of am decluttering. I have a special area for graphing. For interval 1, we have all of our data set up. Interval 2, 3, all of it's right here, all the things that we need. Now in the last video, I went step by step showing you how to put each individual data point on a graph. It was a little slow, and it's a correct way to do that, without making any mistakes. Let's go this time. Let's try to graph all of these data points at once. And I know in the last video, I said try to not do this. Why? Is because it's all going to be one set of data. Let me show you what I mean. So highlighting all of these values, go to Insert, and find where you have a scatter plot chart. That's the one with just the dots, right here. Okay, let me make this a little bigger. All right, all of these data points are considered in one set of data. You could tell because they're all represented in the same color. Okay, since they're all in one set of data, the error bars aren't going to act the way we might want them to. That was the reason for last week us going step by step, inserting the error bars one at a time. However, there is a shortcut to adding the error bars. Let me show you. So since we have our graphing area right here, I'm going to set up right next to our data points. I'm going to put in right here a column for the standard error. So what was the standard error for interval 1? That was, so I'm going to set this cell equal to this standard error down here. I'm going to set that cell equal to this standard error, and I'm going to set this cell for interval 3 equal to the standard error for interval 3. Okay, so now we have a more compact sort of graphing area up on the top. Let's try to add error bars in this new, slightly different way. Okay, so clicking on a blank area on the chart, you could go to this plus sign, chart elements, or you can go click on the chart, you go to design, and go to add a chart elements over here. We're wanting to add error bars, and you're going to go into more error bar options. Okay, we can see that there are horizontal error bars added. We don't need those, so let's click on those and delete. And this is the problem I was sort of telling you about last week in the last video. All of the error bars are the same magnitude because this is one set of data. It would be a little difficult to adjust one at a time. However, since we've arranged our standard error values in such a way like this, let me put the chart right here. Since we have arranged the standard error like so, we can adjust things a little easier. So let's click on an error bar and it'll bring up these options. And we're going to go to custom, specify value. And instead of going one at a time like we did last week, let's highlight this whole column for the positive error value. So click on the arrow and we're going to highlight the whole column. And what this is doing, it's relating that first cell to the first set of data points. It's relating that middle cell to the middle set of data points and the third with the third set. And we hit the down arrow. We do the same thing for the negative error values. And hit OK. Now we can see the error bars have been adjusted correctly for that data point. To maybe make this a bit more clear, let me try to change just one of them. Let me try to grow this, the error values on that first data point. To do that, I'm just going to make, this 6. Let's say we had a data point that was 60 instead. Okay, so see right here, the standard error has changed, and the error bars for just that value have changed. Okay, so this is a shortcut on how to add the standard error bars to our graph. Let's change that back to 6. Okay. Another benefit for having all of our data as one set of data, Excel can automatically fill in a trend line for us. So we can sort of analyze the data a bit more than we could have graphing it the other way in the previous video. So once we have a chart with all of the data points in one set of data, we click on a blank area. In fact, let me get rid of this so we could go from there. So click on a blank area, and you could go to chart elements from this plus sign, or you could go to design and chart element, and we're going to add a trend line. Now we're not going to click on linear just yet. We want to go to more trend line options. Now this new window will pop up. In here we can choose from a set of trend lines we possibly think it could be. We want linear for this specific lab. And that's not exactly all we want. We want something that may be helpful is displaying the equation of that straight line on our chart. So we could click this checkbox down at the bottom, and we have the equation for this straight line. If you remember from math class, that's y equals mx plus b. So m value, that is your slope of the line, and b, that's the y-intercept of that line. You can see that's how we define this. This is going to be helpful for future labs in analyzing data. Okay, we have the slope. That's helpful. What else did we want that was pretty important? let's click on the trend line, make sure this option window pops back up. Down at the very bottom, we could see display R squared value on the chart. We're going to click that. And right underneath the equation has the R squared value. And you can see it is very close to 1. In fact, it's 0.9995. So that means almost all of the data points are exactly on that line. Let me make this a bit more hectic. Let me mess this up a bit. See how this R squared value changes. Let me change this middle data point. So I'm just going to change the data right here. Let's say this point, instead of 7, it was 10. And we're going to make this a bit worse. Say that's 13. Okay, the error bars have adjusted, and the slope of the line is still rather the same. I believe the y-intercept has changed. You can also see the R squared value has changed. It's much worse now. So it's not as close to 1. That's showing that the collective data is farther away from touching that line, from being that linear relationship, as opposed to, I can go back to it, so that was a 7, and that was a 7, as opposed to this, where all of the data points line up almost perfectly on that line. And it's almost a R squared value of 1. Having an R squared value close to 1 represents having the axes being linearly proportional. And that's what we're finding today. Okay, let me just shrink this up a bit. I'll put it right here. Something else we need to do. Let me click out of this. Okay, something else we need to do is graph length squared versus period. And we need to graph length versus period squared. How do we find these? Well, it's as simple as taking this data that we found, that we've measured the best we can. We're only taking that one set of data and calculating the length squared and the period. And we're calculating the length and period squared. So you see down here, for this graph, the length, that's just the length again. It's unaltered. But we need to have the period values squared. Does that mean we take the average and square them? Not quite. We need to square each individual data point and then find that average. So let's try to do that. What you can do is, highlight this calculation table. You highlight and copy and paste and, square the values that way. Or what I like to do, we go up here just to a blank area, and let's add a new column. I have things a bit too compact for me, so let's try to space this out. So I'm going to go and insert a new column. So I want to, actually let me add 2. So I have room to add some things. Oop. That's one more than I wanted. I want to go here. Let's add a few columns. Okay, so I've spaced things out a bit. And we want to find the period squared. So we have the period right here for interval 1. Let's find the period right next to it. We're going to say period squared. And I just simply say that this cell equals its neighboring cell squared and hit enter. Okay, since I have this function in the cell, I can copy that to its neighbors, and it will square each neighboring cell. Something about, copying the function, if I say went one past, it will still do that function, but it is squaring this blank cell. So it's squaring 0 and it's returning 0. Since we don't want that, we just delete that. Okay, now down here I can say average squared. So that's going to average all of these values up here. So that will equal, so I want this cell to equal the average of these values. Okay. Now, something you might say is, why couldn't I just square that average value to begin with? Well, let's try that. So we have this cell down here. This is just going to be the example. This cell equals that first one squared. You see, they're not exactly the same. Now, the reason for this is there is, of course, some rounding error within Excel, and we might address this later in a future lab. The important thing is you can just go in and square each individual one and get the correct value this way. Okay, now that we have this new average, we do that for all of the intervals, and we can find new standard deviations, new standard errors, and plug those into this graph down here. Get a new graph. That's how we do that. For, say, like this length squared, we wouldn't have to physically measure a length and square it. I wouldn't have to find 100 centimeters for that first interval. Right, so I wouldn't physically be doing, the data for this second graph and the third graph. I'm merely only calculating based off of that first set of data. This interval, that would be 900. And the period values would be the same as up here. Okay, hopefully that clears things up with finding the trend line, the r-squared values, a shortcut on finding the error bars. Let me very briefly go over Google Sheets. So we have Google Sheets here. It's okay for finding the trend line. It's not as great for finding the error bars. So what do I mean by this? Let's just jump into it. So like the other way, I can highlight all of the data. In here, I would go to Insert and find Chart. It's going to give me this column chart that I don't want. So we need to change the chart type up here. Going into here, we're going to find these scatter plots with just the dots right here. And that looks better. It's a bit messy with the dots on the very edge. If I didn't want that, I could select this aggregate, and I can then sort of see now this is 0, and it's added another space on the very end, so you can clearly see the dots. In Google Sheets, you can find error bars, but it's not going to give separate individual error bars. So let's go like this. So clicking on the chart somewhere, you will then go to Customize. If it's not already here, you're going to hit Customize. and you're going to go to where it says series. In series, you can go down and see where we can add some error bars. But this is the problem that I've stated earlier. They're all the same magnitude error bars. So that's meaningless to us. We know that each interval has its own separate error. So error bars aren't that great. I could even go in here and find a constant, but they're all going to adjust to that constant. I personally haven't found a way to get around doing that, these error bars. So I'd say Google Sheets is not the best for plotting these error bars. Since it's not the best, we'll just leave them off. Okay, but Google Sheets can do a trend line fairly well. So we'll say trend line. For this set of data, it's added this line of best fit. We can go below this, and there is a box that says show R squared. That is also pretty good. That's what we want. For this set of data, we have an R squared value of 0.982, which is fairly good. Okay. Again, error bars, not great. I would say leave them off and write below what the error should be. Possibly take this over to Microsoft Excel instead. That would be my suggestion. Yeah. So I hope this has been a helpful guide on how to get started with the lab and how to find the trend line, a shortcut for error bars, the R squared value, and just some other basics on Excel.